Okay guys, welcome to this one. So here we need to complete the table for the following integral. So instead of directly integrating it, we're going to use something known as the Trapezium Rule, okay? And the key idea is, firstly, we just need to fill out this table. And this is dead easy. You just plug in the x values into this equation. So I'm going to do the first one for you guys. So suppose we put minus 4. We're going to have 3, oops, let me write it down. We're going to have 3 times minus 4 squared plus 2 times minus 4, add 4. If you did this in your calculator, you should get exactly 44. And well, I've already done the rest, so you just have to keep repeating this process. So in the end, you should get firstly 25 here, 12 here. Let me see my other answers. You should get 5 here, 4, 9, 20, 37, and 60. So double check this yourself, see if you get the same results here. And if you did, then that's good. Alright, so here comes the main point of this question. So here we need to calculate the area under the curve from x equals 1 to x equals 3. And to do this, we just need to use a simple formula, which is known as the Trapezium Formula. Now, and that is delta x over 2. So delta x means the change in x. So what is happening between each x values? Well, it's going up in ones. So we can just say the value of delta x is going up in ones. So 1 over 2 times the initial y. So this formula means y0 plus yf. Y0 means the initial y, so the first y that we're interested in terms of x. Because we're going from x equals 1 to 3, let me just highlight that. Because we're doing these values here, this value of 9 is the first y, is the initial y. And f means the final. So this value of 37 is the final y. And then you write plus 2 times all other y's in between. So because there's only one value between, this all other y is 20. So that's it, guys. That's literally it. So we could say that the area from x equals 1 to x equals 1 through 3 is going to be delta x. So delta x is 1 over 2 times y0, which is 9, plus 37, plus 2 times everything in between, which is 20. And that's it. Literally it. And then now just smash on your calculator. So I'm doing it now. I got, let's see, 1 over 2 times, so make sure you put the bracket exactly as you see here, plus 2 times 20. And yep, I got 43. So the area under the curve is 43. Okay, now let's have a go at plotting the graph for the given function. So we've got the same points from the previous one, so we're still carrying on this question. Now, just plotting this is dead easy, and then we need to show where the area of the curve is. So which is between x equals 1 to x equals 3. Okay, let's do this. So the first things first, let's look at the coordinates. So the way I structured this graph is that I did the x-axis here, the y-axis above, and you can see that I'm starting from 0, 10, 20, I'm going up in tens. The reason why, because we can see that the biggest y value is 60 and the smallest is like 4. So let's just say the smallest is 0. So between 0 and 60, so it makes sense to go up in tens. You can go up in 5s if you like. It depends how big your graph is, as long as your coordinates are fine. And of course, the x-axis goes from minus 4 to plus 4. So let's do this. So from minus, so we can say that the first coordinate, minus 4, 44, should be here. So it should be here. Minus 4, and you go up to 44. So this is 40. The middle is 45, so just before 45, so it's around here somewhere. So I'm going to just mark an X there. Okay, the next one will be minus 3 to 25. So again, start from minus 3 and then go up to 25, and it should be around here. Minus 2, okay, we've done this one, so minus 2 and 12, so minus 2, 12, so 10 is between 10 and 15, so it's around here. Minus 1, 5, so it should be here. And then 0, 4, so 0 is in the center, 4 is just a bit less than 5, so somewhere here. So you can see it looks like a nice swift curve. Okay, let's keep going. So 9, so 1, 9, so 1, 9 is around there. This one would be 2, what's it going to be? 220, so yep, here, bang in the center, 220. 337, so 35 is here, 37 is here, between 35 and 40, and then 60 is right at the top for 4, so here. And that's it. Now we can just just connect them up. So let's try and sketch it. So I'm going to use, frankly, I'm using a computer, so this is easy for me. So I'll just use something. Let's see. So I'm just doing this on PowerPoint, by the way, if you're wondering. So connect this. Oops, that's not what I'm supposed to do. So yeah, just have a go at joining this up. This is obviously easy. So make sure it's a nice curve, yeah. Okay, and that's it, done. And that's literally it. So now you've got it, you're literally done. And this is how the curve should be. And if you remember from the other question, it said we need to calculate the area under the curve from x equals 1 to x equals 3. So this answer 43 came from here. I'll tell you what, it looks a bit like this. So all you do is literally from x equals 1, draw a straight line down, and then you do another one, use your ruler, draw another straight line down from x equals 3 right down to the line. And then what you're really doing is that you're finding the area of this region here. So let me just shade that in, yeah. So you're finding the area of this entire region. And the only way to do this is to use the trapezium rule. That's it. That's actually how you do it. So you can see that this is some kind of trapezium. That's what the equation means.